What's up, folks? Welcome to Math Walkthroughs with Mr. Weeb. Today we are solving problems involving decimals and whole numbers in our Lesson 5 action task. In order to solve these problems, we're going to use the UPS check method. This is where first we need to understand the problem, where we read the problem first. What are we looking for? We're going to bracket the actual question. We're going to circle the important numbers and underline what those numbers mean. Then we're going to plan a strategy. We're going to choose a strategy, and there's a bunch of options that we could have, and then we're going to actually do the work and solve and label our answer. So we wouldn't just include 3 plus 5 equals 8. We would have to include the word as well, and we may even write an entire sentence. And last of all, and this is a very important step, is to check, reread the problem, and make sure that we actually answered the question and figured out, is our answer actually reasonable? Let's try it with this first one. What is the cost of 5 boxes of cereal? So not many words to this. This is the actual question, so I'm going to put brackets around it. I'm going to circle the important numbers. 5 is one important number and $4.29 is another. But what are those numbers? Well, we have 5 boxes of cereal. And the 429 refers to the cornflakes. So we'll underline the cornflakes. Next, we need to make a plan. Well, I have 5 boxes of cereal. It sounds like I have 5 groups of 429, so I'm going to write a number sentence for this one. My number sentence would be 5 groups of $4.29. I can put that into my traditional algorithm and multiply. 5 times 9 is 45. The 4 carries up here. 2 times 5 is 10, plus 4 is 14. 4 times 5 is 20, plus another 1 is 21. Then I see how many numbers are behind my decimal, or to the right of the decimal, in the question, and it is 1, 2. So I should have 1, 2 decimal places in my answer. Now, the very important step at the end of the question is to do the check, right? We've solved it, and I should check, does this answer make sense? Well, if I'm getting 5 times about 4, I should get about 20. And since I have more than 4, I should get more than 21 in my answer. So I'm pretty confident that this is the correct answer. All I have to do now is answer it in a full sentence like this. 5 boxes of cereal will cost $21.45. Let's look at the next one, and we're going to use our UPS check first. We're going to understand it. So we'll read the whole question. A rectangular stage in the park has a length of 4.25 meters and a width of 6.4 meters. What is its area? Okay, first I'm going to bracket the actual question. We want to know, what is its area? Then I'm going to circle the important numbers. It looks like we have 4.25 meters and 6.4 meters. What does that mean? Well, the 4.25 meters talks about the length, and the 6.4 meters is the width. Now I know that to find the area of a rectangle is going to be the length times the width. So, in this case, my area should be 4.25 times 6.4. Let's stack them up and go through the algorithm. Remember, when we're multiplying, we don't need to line up the decimals. That's for adding and subtracting. I'm going to go through 4 times 5 is going to be 20. 2 times 4 is 8, 9, 10. When I add the 2. 4 times 4 is 16, and add the 1 is 17. Now I'm going to put the 0 first before I start multiplying 6 by everything. So 6 times 5 is 30. Put the 3 up here. 6 times 2 is 12, plus 3 is 15. 6 times 4 is 24, plus 1 is 25. Now we add this all up. We've got 0 here, 12 here, 5, 6, 7. And a 2 there. Now we just count how many numbers are behind the decimal, to the right of the decimal. We've got 1, 2, 3. That means we should have 3 decimals in the question as well. There we go. So the final area is going to be 27.2 meters squared. Does this make sense? That's what we need to do with our checking of the answer. Check, does this make sense? If I were to estimate this, this number would be close to 4. This number would be close to 6. So 4 times 6 is 24 meters squared. But since this is more than 4 and this is more than 6, I would expect our area to be more than 24 meters squared. So now I'm fairly confident about my answer. Now I can put it in a sentence. The area is 27.2 meters squared. Remember to keep that meters squared in there if we're talking about area. It's not a linear meter, it is a square meter. Okay, let's go to the next one. It says, Maya needs a piece of wood 3 times as long as the one she has. How long does it need to be? First, using the UPS method, first we have to understand what is the actual question. There it is right there. We put that in brackets. Then we're going to circle the numbers, the important numbers. Looks like the one that she has is this long, but she needs it to be 3 times as long. What does this mean? Let's say what this means. 3 times as long. 3 times as long there. And 1.88 meters is the piece of wood. .88 is the one she has. Let's put it like that. Okay, next, now that we have labeled everything that we need to, next we are going to come up with a plan. The plan I'm going to use is to make a number sentence, because 3 times as long, that suggests that I need to multiply. I need to go 3 times 1.88. So let's stack them up here and go through this. 3 times 8 is 24. Bring the 2 up there. 3 times 8 is another 24. Add the 2, and I've got 26. 1 times 3 is 3, 4, 5. That's it. Now I just see how many decimals, how many numbers I have to the right of the decimal in the question, and I have a total of 2, so there should be 2 in the final number. Now the last question I should ask myself is, does this make sense? That's the check part of the UPS check. Check to see if it makes sense. If I were to estimate this, I would say that this number is very close to 2 and this number is 3. 2 times 3 is 6. Is this number very close to 6? Yes, it is. And it should be a little less than 6 because this number is a little less than 2 anyway. So now that I'm confident, I'll put it in a sentence. The piece of wood Maya needs is 5.64 meters long. And don't forget to have your units as well. Let's go to the next Group B problems. The first one in the Group B problem says, Aiden has 9.8 kilograms of craft sand to separate into 4 equal packages. How much sand will be in each package? Let's put a bracket around the actual question, which is this. Let's circle the important numbers. And let's label what those numbers mean. 9.8 kilograms of craft sand, and this is 4 equal packages. Okay, now I need to plan. Now that I understand what the question is, I need to make a plan. So my plan is to have, I need to divide this 9, almost 10 kilograms of craft sand equally into 4 equal packages. So basically what I'm doing is I'm going to take 9.8 kilograms and divide it among 4 packages. Okay, so let's do this. We can set up the question like this. 4 into 9.8. How many times does 4 go into 9? It goes twice. 2 times 4 is 8. We subtract. We get 1. The 8 comes down. 4 goes into 18 4 times. 4 times 4 is 16. We do subtraction. We get a 2. There are always more zeros to bring down. So we've got 2 here. 4 times 20. 4 goes into 25 times. So that will work out. 5 times 4 is now 20. So we're done. Then we just put that decimal right here. And if we think about it and we go, okay, well, what would we expect, right? This is the checking part of it. We would check and see how many times would we expect 4 to go into 10, right? We would go 2 times and a half, 2.5 times. And I'll tell you what, this is very close to 2.5. So this makes sense. Let's now put that in the form of a sentence. There will be 2.45 kilograms of sand in each package. And notice I'm putting a box around all my answers. It's much neater that way, and it's easy to see what your answer actually is. Next, Nala has 5.5 kilograms of trail mix. She needs to make up packages of 0.125 or 125 thousandths of a kilogram. How many packages could she make? 125 thousandths is the same as 1/8 of a kilogram, but that doesn't really matter. Let's go ahead and do the UPS check. First up, what is the actual question? The actual question is right here. We put that in brackets. How many packages could she make? That's what we want to know. Then we're going to circle what we think are the important numbers. And we're going to underline the labels. The 5.5 refers to the trail mix. The 0.125 is packages. How many packages could she make? So basically what we're asking is, how many times could this number fit into this number? Well, that's a division question if I ever heard one. So let's do that over here. We need to find out 0.125, how many times that fits into, oh, that was a crazy line I just drew, 5.5. Now I don't like to have any decimals in this number here. So let's get rid of them. We're going to move it 3 spaces to the right and rewrite the question. So it'll be 125 into, and we will also have to move this decimal place over 3 spaces. So it's actually going to be 5,500. Okay, 125 goes into 550 how many times? Well, let's see. 125, 250, 375, 500. So 4 times gives me 500. I do the subtraction. That's 50, and there's 500. So that means that 4 times 125 will give me 500. And we have no remainders. So that's pretty good for Nala. Nala can make exactly 44 packages. And we'll write that in a sentence. Nala can make 44 packages. Now I haven't done the check part of the UPS check. So the check part could look something like this. Does this make sense? I can put this on a double number line, okay? Where here's 0 kilograms on the bottom, and we can have packages on the top. Okay, and then we have 1 kilogram, 2 kilograms, 3 kilograms, 4 kilograms, 5 kilograms, 6 kilograms, and here's 5.5. This would be 5, 4, 3, 2, and 1. I know that this is 1/8, or you can fit 8 of these into 1 kilogram. So for every kilogram, Nala can make 8 packages. So that would be 8 packages. When there were 2 kilograms, she makes 16. When there are 3, she makes 24. When there are 4, she makes 32. When there are 5, she makes 40. And then we would expect if she made 6, it would be 48. But it would be half that, right? If halfway here would be 4, right? So that means halfway here would be 4 as well. So this would have to be 44, and it does make sense. We just did it, instead of with a picture or with a number line, a double number line, we did it with just division. Again, either one of those solutions is good. Let's move on to our Group C problems. Number 6 says, Nori pays for 2 movie tickets, 2 boxes of popcorn, and 2 drinks. How much change would he get from $40? First, understanding the problem, what is the actual question being asked? I'm going to put that in brackets. Next, I'm going to circle the important numbers. 2, 2, 2, and 40. There's more numbers to be involved in this one. And what does the first two mean? Well, those are the movie tickets. We've got boxes of popcorn and 2 drinks. And then the $40 is how much money he starts with. So there's nothing to underline there, but that's okay. Let's keep going. The other numbers we have are here. We've got the actual prices of these things, right? So that's important. Next, we've got a plan. We've got to plan what we're going to do. First, we have to figure out how much is it going to cost for 2 movie tickets, how much is it going to cost for 2 boxes of popcorn, and how much is it actually going to cost for 2 drinks. We can solve all of this by making a number sentence. Okay, so I'm going to construct that number sentence right now. 2 times $12.99, and I'm going to put brackets around that to show that means my movie tickets. Okay, that's the price of my movie tickets. Then I'm going to add to that the 2 boxes of popcorn in brackets. 2 boxes of popcorn, so that's $2.99. Then I'm going to add to that 2 drinks, so 2 times $1.99. And then all of that should be my total that I would spend. Okay, so let's rewrite this after calculating all of those amounts. These are easy enough to do in your head. 2 times $12.99 is very close to 2 times 13. So I'm going to pretend that the $12.99 is actually a 13. So that would be $26. But I know that that's 2 cents too much, so I will go $25.98. So the first one is $25.98. Next, we're adding 2 times almost 3. So let's do that. 2 times 3 would be 6, but now I've gone 2 cents too many, so I should add $5.98. Same thing with this one. 2 times $1.99 is almost like 2 times 2, which is 4. But I know that I should take away 2 cents. So I have $3.98. And now we can add all of those together and come up with an answer. We could stack these all together, but this is doable in our heads as well, because we can add just the ones and tens together. So let's go 25 plus 5 is 30 plus 3 is 33. And then these are all very close to $1, right? So we've got 33, 34, 35, 36, and then we've added 2, 4, 6 cents too much. So we'll take that 36 and subtract 6 cents. So we should have $35 and 94 cents. I'm going to double check that on my calculator. Now we have what looks like it could be the answer. However, we have to always do the check, right? Our check is, have we actually answered the question? And the question was, how much change would he get from $40? We figured out how much they spent, but if you gave $40, like a couple 20s, and you only spent $35, you'd expect to get some money back, around $5, well, more like $4. So how much would you get? Here we need a subtraction question. How much more is 40 than 35? And remember, if you're subtracting, you do have to line up those decimals, and we're subtracting here. So this might be easier to do in your head as well, because this is very close. This is very close to 100 cents, right? I could see how much would I need to add to this to get to 40. That's another way of thinking about subtraction. So I would need to add 6 cents to get to 36, and I would need to add $4 then to get to 40. So it would be $4.06. And that should be our final answer. And all we need to do next is put it in a sentence. He would get $4.06 in change. Number 7. A hexagon has sides that are not all equal in length. The perimeter is 1 4700 meters. How long might each side be? Ooh, this is tricky. But let's continue with our UPS method. And first, with our understanding, just put a bracket around the actual question. How long might each side be? It sounds like there might be multiple answers to this one, but let's see. Next, let's circle the important numbers. We've got a perimeter that is 1.47 meters and a hexagon. Well, a hexagon has 6 sides, so we might just want to add in 6 and circle that important number. Then we should underline the labels. The perimeter is 1.47 and we have 6 sides that are not all equal in length. Okay, a perimeter, with this one, I might want to do something different than with a number sentence. My strategy or my plan might be to draw a picture first. A picture of a hexagon. So let's go ahead and do that. I'm going to draw this hexagon. It's not going to have all equal sides. 1, 2, 3, 4, 5, 6. Okay, and we know that adding all of those lengths up would be 1.47. So something plus something plus something plus something plus something is going to be 1.47 meters. My strategy might be to say that, well, I can have some of them be the same. So maybe this one, I might just do a guess and check. Let's try this. How about this one 0.5 and this one 0.5? That's going to equal 1. Okay, then I only need 47 hundredths of a meter left over. So let's say that this one is 10. This one is 0.1, sorry. And this one is 0.1. Okay, so that's 2. This one could also be 0.1. How much do we have so far? Right? We've got 0.5 plus 0.5 plus 0.1 plus 0.1 plus 0.1, and we've got 5 of the 6 sides together already. So this is 10, 11, 12, 13. So we've got 3. We've got 1.3 so far. And we need 1.47. So if we just go 1.47 and subtract 1.3, then we should figure out how much this last side needs to be. So 7 take away 0 is going to be 7. 4 take away 3 is 1. And we need this one to be 0.17 meters. And this would be an okay answer. Just like this, as long as each of them has the units that we're talking about. So 1/10 of a meter, 3 sides are 1/10 of a meter, 2 sides are 5/10 of a meter, and 1 side is 17 hundredths of a meter. And that is our answer. Does it make sense? Well, we know that we added these up. When we check it, we added these up, and then we added this one onto it, right? If we double check and see that 1.3 plus 0.17, excuse me, it should be 1.47, right? This is 7, this is 4, this is 1, yes. If we add them all up, it does equal 1.47. So you had to know that the perimeter is something that you add all the sides. Number 8 says, a car uses 4.2 liters of gas to go 50 kilometers. Gas costs $1.29 per liter. How much would it cost to go 200 kilometers? First step, what is the actual question? I'm putting brackets around that. Next step, circle the important numbers. Looks like we've got a bunch of important numbers here. Then we say, what are those things? The 200 refers to kilometers. The 129 refers to per liter. The 4.2 liters refers to gas. And the 50 refers to kilometers. So we've now understood the question. We want to know how much it would cost to go 200 kilometers. Now we want to need to make a plan. What can we do with these numbers to make them make sense? It's like a puzzle. We got to put it all together. So the car uses 4.2 liters of gas to go 50 kilometers. How much would it cost to go 200 kilometers? I think what I'm seeing in my head is a double number line. I love these. So if they had gone 0 kilometers, we'll put kilometers on the bottom, and we'll put the amount of gas on the top. The gas in liters. Okay? We know that we want to figure out how much would it cost to go 200 kilometers. So that means 100 would go right here, 50 would go here, and 150 right here. Okay, how much gas does it take to go 50? Well, we already know this, right? The gas would be 4.2 liters to go 50, and another 50 would be an additional 4.2. So I can just add another 4.2, and we'll get 8.4. I can continue adding 4.2. If I add 4.2, we get 12.6. And if I add another 4.2, we will get, 16.8 liters. All right. So how much would it cost to go 200 kilometers? Does this make sense? Well, it should cost, since 50 times 4 would give us, and I'll just write this in, if we multiply this by 4, we get to 200. So then we should have 4 times as much gas as well, right? If we multiply this by 4, 4 times 4 would give us 16, and a little bit more than that would be 16.8. So we've done a bunch of math already. Have we solved the problem? The last step we need to do is we need to check. Have we actually answered the question? The question was, how much would it cost to go 200 kilometers? All we've found so far is how much gas we would use to go 200 kilometers. But if we know how much gas we've used, we can just multiply that by the price per liter, right? If 1 liter would be 129, then 16 liters would be 16 times as much. But we're not getting exactly 16, it's 16.8. So all we need to do is set it up like this. We've got $1.29 times 16.8. We multiply those together. Let's go ahead. 8 times 9, 72. 2 times 8, 16. Plus 7, 13. Carry the 1. 1 times 8 is 8, plus 1 is 9. Put a 0. 6 times 9, 54. 6 times 2 is 12, plus 5, 17. 6 times 1 is 6, plus 1 is 7. Now we need to put 2 zeros when we're doing the 1 times everything. 1 times 9 is 9, 1 times 2 is 2, 1 times 1 is 1. I've run out of room, unfortunately, but I'm going to keep going. We've got 2 here, we've got 7 here, we've got 9 plus 9 is 18, plus another 7 is 25. Carry the 2 over here. 2 plus 2 is 4, plus 7 is 11. Carry the 1, and we've got a 2 here. Next we look, how many numerals do we have behind the decimal point to the right of it? We've got 1, 2, 3. So we should have that many decimals in our answer. $21 it looks like, and 57 cents. Okay, we wouldn't have, we can ignore this one. We can just round it down to 57 cents. And I think if we double check now, I think we've answered the question, how much would it cost to go 200 kilometers? It would cost $21. Let's write that down. it would cost $21.57. Next, and I think it's the final one? Yes, it is the final one. On Monday, there was 2 liters of mint ice cream. Each day, for 3 days, the amount went down by about a quarter of a liter. On Thursday, there was an 8/10 of a liter of mango sorbet. About how much more mint ice cream was there than mango sorbet on Thursday? All right, this is getting more and more complex, isn't it? So the question it's asking is about how much more mint ice cream was there than mango sorbet on Thursday? That's the question it's asking. Now we got to circle some important information. 2 liters refers to the mint ice cream. Then we've got 3 days. The amount went down by about 0.25 liters. That refers to the amount that it went down by. Then on Thursday, there was 0.8 liters of mango sorbet. The 0.8 liters refers to the mango sorbet. And then how much more mint ice cream was there than mango sorbet on Thursday? So we care about the Thursday's amount. We started with 2 liters of mint. So we got to figure out how much is left on Thursday of the mint ice cream and how much was left on Thursday of the sorbet. Should we start with the mint? Okay, let's start with mint. We had 2 liters of mint ice cream. I'm going to put it in a number sentence. We started with 2 liters. And I'm going to actually label this just to keep it all straight. Mint calculations over here, sorbet over here. Let's keep our thoughts organized, because when there's so many numbers, I can't even keep it straight. So in mint, we started out with 2 liters. Then we had to subtract, right? If the amount goes down, it sounds like we're subtracting. So we subtract minus 0.25, and we subtract another 0.25 and another 0.25. If we subtract all of those from the 2, then we should end up with, I'll put this on a number line. I'm going to put this on a number line real quick. Hold on. I think a number line is, a picture speaks 1,000 words, doesn't it? So here, we started out with 2. And let's say this is 0, okay? And this is 1. A quarter of a liter, right? It goes down by. So here's 1.5. Here's 1.75. Here is 1.25, okay? It goes down by a quarter of a liter, 0.25. We subtract minus 0.25. Then we take another subtraction, 0.25. Then one final subtraction of 0.25. So this here represents Monday, and then Tuesday, Wednesday, Thursday. This here is Thursday. Thursday is 1.25 liters of mint ice cream. Okay, how about for the sorbet? On Thursday, there was we know that on Thursday that there was 0.8 liters of mango sorbet. And the question was, how much more mint ice cream was there than mango sorbet on Thursday? Well, if it's how much more, that sounds like a subtraction question. So I'm going to start with mint, and I'm going to subtract the amount of mango sorbet. And I had 0.8. Remember, when we're subtracting, we need to keep those decimals one on top of the other. And now we just need to subtract. 5 take away 0 is 5. Then 12 take away 8. Right, I can't go 2 take away 8, so I'm borrowing from the 1. But, I mean, I don't need to do that. I just go 12 take away 8, and I should have 4. The decimal gets carried down, and I've got 0.45 liters. Does this make sense? I should just ask myself, does this make sense? It does make sense that we would have 1.245 liters on Thursday, and when I subtract that 0.8, I should have about 0.45 liters. It does make sense to me, so I'm just going to write it in a sentence finally. There was about 0.45 liters more mint ice cream than mango sorbet on Thursday. That's it for today. Thanks for watching.